Okay, hello. My name is Haley Barlow. I am a PhD student, and I'm here today to tell you about your exploding pancreas. So, what the heck am I even talking about? What does that even mean, my exploding pancreas? Well, what I mean by explosion is the rapid and stunning changes your pancreas undergoes during development, or the period where, before we're born, where we're all growing into the beautiful babies we all were. Before we get to the explosion, let's circle back and discuss what is the pancreas and who cares? Well, we all have a pancreas. It is this awesome organ that hangs out right by your stomach and is all wrapped up with your intestines. The pancreas is an extra special organ because it is actually a 2-for-1 deal on organs. It has parts that make the acids we need to digest our food, and it has parts that help us regulate our blood sugar by producing a chemical called insulin, which you may have heard of. Therefore, the pancreas is necessary for us to live because to live, we need to be able to get nutrients out of the food that we're eating. And additionally, the pancreas is where things go wrong when people become sick with diabetes, which is a huge problem for lots of people. And more people are getting it every day. Probably each of us knows someone who has diabetes. So the problem that my lab is hoping to help solve is how can we cure diabetes if it is such a huge problem? Our goal is to figure out how to grow the pancreas cells that get sick and cause diabetes outside of the body so that we could transplant those cells back into a diabetes patient and voila, they would be cured. But these cells are very special and scientists don't know how to grow them yet very well. Enter the pancreas explosion. My strategy to get at this question is to study the ultimate cell builder, the developing embryo, to figure out what these diabetes related cells really need to grow and to thrive. So, okay, again, we've been listening to me talk for a good little bit now and still nothing about explosions. So, the pancreas inside each of us right now is this big branched organ that looks kind of like a tree. All the leaves at the end are cells making digestive acids, and the branches are cells that direct the flow of these acids into our guts. The diabetes related cells, called endocrine cells, are like little squirrels perched throughout the tree, snuggled up, taking a little nap, hanging out amongst the branches. But the pancreas does not start out looking anything like a tree. Similar to how a seed doesn't really look very much like a tree, when the pancreas first begins to develop inside of a growing baby, it starts out as a little ball of cells. This ball grows and starts to have little bumps on it. And then, boom, it rapidly transitions into a whole bunch of branches that are all connected, going all over the place. But at this point, they don't really look like a tree. They look more like a fishing net with lots of branches going in all kinds of directions. Even though this transition stage may not seem that important because it isn't how the pancreas starts and it isn't how the pancreas ends, this is actually where we think these endocrine cells thrive. They grow here like crazy. And then as the pancreas starts to look more like a tree, they start to slow down a little bit. So, my job is to try to understand how the pancreas transitions from a small ball to an explosion of branches. And hopefully, we can use what I learned from my work in the lab to find ways to mimic that explosion to encourage diabetes related cells to grow outside the body and hopefully cure diabetes. Thank you guys so much for listening, and I look forward to chatting.